So here's the definition of a set. A definition must classify what something is and how it differs from other items and classes without giving counterexamples. That's kind of, oops, I don't know what happened. Let me reconnect. Did everybody receive my link for the book too? I found it for like, yeah, I don't know. Did anybody purchase it through that link that I sent or no? All right, well, that's an option. So what a set is, it's just basically it's here it is. A set is a blank which are called elements or members of the set. So let me just give you an example and then we can kind of see what it is. So a set can be anything like, for example, you can define it to be A or B or any letter, and it can have anything inside of it. It can have like numbers, letters, names, cities, anything. So I'll just go with California, Arizona, Texas, New York. That's good enough. So those states, that would be an example of a set. And it has how many elements?
1, 2, 3, 4.
Four elements. Yeah, that's right. This set has 4 elements. So it's just a collection of objects, which we call elements. So that's what we can say. So set is equal to a collection of objects, which are called elements. So a collection of objects. In this case, the objects are states, but it could have been anything. It could have been numbers. It could have been people's names, presidents' names, things like that. So anything you want it to be. All right. So here, let's see, they give us an example. The United States is a set of 50 states plus the District of Columbia. Okay. 3 common methods to indicate a set. There's 3 different ways you can list it. This is called the listing method, when you just list them all out. All right, so let's do that. So 1. I'll just name it here. Sorry. So this is the listing or roster form, as they call it. It's basically when you just list out the individual elements like that. All right. So my computer for some reason keeps on freezing and then it throws me off. So I have to keep on reconnecting. So if this happens, I might have to restart my tablet. So let's just see if it happens more. All right, so that's what one form of a set will look like. It's called the roster form, also known as a listing method. And notice these braces. You always have to have the braces to open and close your set. If it doesn't have the braces, it's not a set. So you definitely have to have these 2 braces on both ends. It's like parentheses, but they're a different type of parentheses. So that's important. You also want to separate the elements with the comma. That tells you that you have a different element in the set. And what else? The order of the elements does not matter. So if I switch California and Arizona, it's the same set. It doesn't make a difference what the order is. As long as you have these 4 states, it's the same. So if I had New York, California, Arizona, Texas, are those the same sets or different?
It's the
same.
It's the same.
Yeah, it's going to be the same set because the order doesn't matter.
I have a question. Could it be more than 4?
Yes, it can be more than 4, definitely.
Okay.
It can even be infinite too. It can be like infinite set. So there's also infinite sets.
Okay.
And the name of a set starts with is always a capital letter. So see how it's capital A is the name of the set. So, or it could be capital B or capital C, but it just has to be a capital letter. Doesn't matter, and braces. All right, so those are the 3 things that you want to make sure you have in a set. All right, let's look at at this example. Express the following in roster form. Set A is a set of natural numbers less than 5. So does anybody know what would be included in this set?
1, 2, 3, 4.
2, 3, 4.
Yep, that is correct. Very good. Because those are the numbers that are less than 5. Natural numbers less than 5. Perfect. Okay. Set B is a set of natural numbers less than or equal to 75. Whoa. Okay, how would you do that one? One, two, three. In this case, it's going to take too long and to write out all 75 numbers, right? So let's just do dot, dot, dot. That means it continues.
And then 74.
Oh, 74.
And then, but notice it says or equal to as well. So it
And
can also-
75.
yeah, and 75. Very good. There it is. And don't forget your braces in the front and the back. All right, set C is a set of days of the week. Anybody know what would go in this set?
Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So SMTWTHFS.
Yeah, very good. I'll just call that one SA because so we don't confuse it with Sunday. But yeah, you could also write out the entire name if you wanted to. You could write Sunday, Monday. If you wanted to write it out, you can. So, or you can abbreviate it like us. All right, set D is the set of
5,
natural
6, 7, 8.
Yep, 5, 6, 7, 8, because those are the numbers that are between 4 and 9. All right. Set E is the set of natural numbers between 4 and 9 inclusive. Anybody know what that word inclusive would, how does that change the answer?
So is it 4, 5, 6, 7, 8, 9?
Yeah, you got it. You just have to include 4 and 9 as well. So that's what inclusive means. You're just including it. Very good. So that is it. All right, so that's how you do sets using the roster form. So now let's look at the other two forms. So the next is called set builder. This one's a little bit harder to read, but set builder looks like this. It's the set of all x such that, and then here you write what the condition is. So let me just write this. The set of x, the set of all x such that, there's a such that, the bar means such that, and then here you would write such that the numbers are between 4 and 9, or all the numbers that are less than 5, or whatever the case is. So this little e, that means is an element of. See that little notation? That means is an element of. All right, so for example, if you have this set A right here, 1, 2, 3, 4, you could say 3 is an element of set A because it's in there, right? So therefore it's an element of the set. You could also say 3 is an element, and then you could write the whole set out. But I think it's a little bit easier to write just the A. It's shorter than writing out the whole set. How about 7? Do you guys think that 7 is an element of the set A or no?
No.
No.
No. So you would say 7 is, whoops, not an element of A. So you just put a slash through the E. That means not an element of. All right, so that's what that notation means. Let's go down here. So what does this mean? It means the set of all x such that x is an element of the natural numbers and x is less than 10. So what would be the roster form if it's all the natural numbers less than 10?
1 through 9.
1 through 9. So the reason why they came up with this is because this is a little bit shorter to write than this. Imagine if it says all the numbers less than 100. Nobody wants to write all the numbers to 100, so they would just write it in this way, and they would just say 100. And it's a little bit shorter to write. So that's the reason. So let's just write the description. Set A is all x such that x is a natural number less than 10. So that's a description. If you wanted to write it out in words, set A is all x such that x is a natural number and is a natural number less than 10. Here's a natural number part, and here's a less than 10 part. All right, so that's called set builder notation. So if we go back to our notes over here, I would write set builder. Notation, I guess you could write that notation. All right, so that's the second type of sets that there are. So here are two more examples, set A and set B. So for set A, let's write it in roster form right here. Let's do this part first. Roster form. So anybody know what would be in the roster form for set A?
So 2, 3, 4, 5. I mean, 3, 4, 5. I'm sorry.
Yeah, 3, 4, 5. Very good. Because see how this one does not have the
It's greater than 2, but it's equal to 5.
Exactly right. Yeah, it's greater than 2, but less than or equal to 5. So that means we would write 3, but not 2, 4, and 5. Very good. And then for set B, what would set B be?
Set B.
The same thing.
Yeah, it looks the same, but the only difference is this. See how this one?
Oh,
It
to be
has the
element.
the element
yeah,
of
the element.
the element of a natural number. That means that x is a natural number, but here it doesn't say that. So this one's too difficult to write. We couldn't write it all out because there's infinitely many possibilities. You can have B as
Because it could be I'm gonna say it could be a decimal because there's no natural number.
Exactly. There's like infinitely many decimals you could write. So I couldn't possibly write them all out. Imagine all these decimals you could possibly write out. There's so many decimals. So you couldn't write them all out.
Answer would be it can't be written in roster form because there's too many answers.
Yeah, that's yeah, so let's just write that. So I'm just gonna stop here and just say ... infinitely many possibilities. So I'm just gonna say cannot be written in roster form because there are infinitely many possibilities. Yeah, well, it disconnected, huh? All right, so I hate that it keeps on doing that. I don't know if it's my internet or if the tablet has to be restarted or something, but here it is. So I just said that it cannot be written in roster form because there are infinitely many possibilities. So the main difference, or the biggest difference was that this one it's an element of the natural numbers, and this one did not say that. Therefore, you can have decimals. All right, so explain the difference between set A and set B. The difference is set A has x an element of the natural numbers, and set B does not. All right, so that's the difference. All right, now they want us to do the opposite. This time they give you the roster form and they want you to write it in set builder form. So let's see. So you always started off with x such that. That's how you always start the set builder no matter what. Then you have to write the condition. What kind of numbers are these? Are they natural numbers?
Natural numbers.
Natural numbers.
Yeah, natural numbers. So therefore we have to do x as an element of n. Oh man, it froze again. Okay, gosh. Yeah, I'm gonna have to just disconnect this and restart it. So just give me a moment and I'll be back in like 2 minutes. I'm gonna restart this and see if that fixes. There's no decimals. So therefore we have to write X is an element of E. All right, so let's do that now. X is an element of N, I mean. And X is, what would you say it's between? Or X
I would
is,
say it's equal or greater to 1 times equal or greater to 5.
yeah, but because it's a natural number, you only have to say that it's less than or equal to 5. Because natural numbers start at 1, so all you have to do is say 5 less than or equal to 5 is good enough.
Got it.
Yeah, all right. But you could also say greater than or equal to 1 if you wanted to. That's fine too. All right, let's look at B. B would be the same thing, X, such that X is an element of the natural numbers. And how would you write this one? So it looks like it's,
That's where you will put greater than 5, but equal to or less than 10.
Less than 10.
yeah. And notice I have the equal on both sides because I also want to include the 5 and include the 10. So you have to put equals on both for both of them. All right, very good. All right, the last one, notice it has dot, dot, dot. That means it continues forever. So this one's an infinite set. So let's see if we can write this X, the set of all X such that X is a natural number. And what do you guys notice about these numbers? What are they multiples of?
Threes. No, is it fours?
No, you got it right the first time. It was, these are
3.
multiples of 3. Yeah, 3, 6, 9, 12 are all multiples of
Yeah.
3. And so I'll just say, and X is a multiple of 3. That's it. So that's set builder notation. All right. All right, cool. So anybody have any questions on these two types of sets? So far we have roster and we have set builder. So let's look at, I think there's one more. So let's see what the last one is. Oh, okay, there, it's over here. Okay, well, let's continue. Write this in roster form. So this one would be D equals, what would be the first number in this set if you're writing it in roster form?
1.
Yeah, and then it would go all the way to 4 or 5.
4, because it doesn't say equal to 5. It just says less than 5.
Yeah, very good. It doesn't have the equal, so you're right. Awesome. All right, the next one is E. Which one would this start at?
2. 2 through 7.
2 through 7. Very good. You got it.
7.
Yeah, so it looks like you guys are getting it. If it has the equal, you have to include it. If it does not have the equal, then you do not include the last number. All right, next one is F equals. All right, how would, what number would be?
27, 28, 29, comma, dot, 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 then 99.
99.
Yeah, very good. Yeah, very good. The dot, dot, dot is just because we don't want to write all the numbers in between. That's going to be way too long. So this is perfect. All right. The last one of this kind is G, which is equal to
2, 4, 6, 8, dot, 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 because it's infinite. It just says even.
yeah, you got it. It's an even, which means there's infinitely many even numbers in our world. So we just have to do dot, dot, dot. And that tells you that it continues on forever. All right, perfect. Yeah, so we have two types of sets. We have finite sets and infinite sets. Finite sets are the ones that stop. Like this would be a finite. Even this one's a finite because it stops at 99. But this one continues forever because of the dot, dot, dot. So that would be an example of an infinite set. All right, so here we just have to say whether it's finite or infinite. So what do you think about the first one?
Infinite.
Infinite.
Infinite for sure, because of the dot, dot, dot. All right, what about this one?
Finite.
Finite.
Finite, very good. What about C?
Finite.
Let's see.
Yeah. Yeah, you guys agree with that? Because it's all the multiples of 5 between 19 and 41. So the first number would actually be what? What's a multiple of
20.
5?
The first number will be 20 and the last number will be 40.
Yeah, that is right. So that's what that set would look like. It would be 20, 25, 30, 35, 40. That's not too many. We could have wrote them all out, but all right. All odd numbers greater than 31. That'd be infinite.
Infinite.
Yeah, because there are infinitely many odd numbers. And if it's greater than 31, the next one would be 33, 35, 37, ... All right, that is right. Very good. All right, let's see if there's more. Yeah, I think this might be the last page, or no? Yeah, this is the last page because that's the same thing. All right, so we got one more page to go. All right, the cardinal number of a set A symbolized by this n parentheses A is the number of elements in a set. So that's what cardinal number means. It just means how many elements there are in the set. And this is a notation that's used. So for the first one, anybody know how many elements there are there?
3.
3.
Very good. So you would just say n of L is 3. So that little n just stands for the number of elements in that set. All right, what about n of m?
5.
Yeah, 1, 2, 3, 4, 5.
5, very good.
5.
All right, what about, this one's gonna be a little bit more challenging because it's in set builder. What about the number of these? So you might want to write this in roster form first, and then you can count them. So try to write it in roster form first. Or let's just write out all these numbers, and then we can cross out the ones that are not divisible by 5. So what would be the first number? Careful. This one says whole numbers. Remember, natural numbers start at 1, right?
Yeah.
Right.
Anybody remember what whole numbers start at? 0. So the whole number, yeah. So the first one would be 0, and then 1, 2, all the way to
17.
17. But then we have to, it says, and it has to be divisible by 5. So which ones are divisible by 5?
5, 10, 15.
15.
Yeah, so 0 is 0. Zero is a tricky one. Is 0 divisible by 5? Can you divide? That's one of those exceptions that I forget if 0 is divisible by 5 or not. Let me just Google it real quick. When in doubt, you Google, right? All right, so you guys agree that these for sure are divisible by 5, right?
Right.
So now we just have to figure out whether 0 is divisible by 5. I think by definition it might be, because it doesn't have a remainder, right? 0 divided by 5 is 0. It doesn't have a remainder. But just to be on the safe side, I'm going to Google it real quick. Google, is 0 divisible by a number? Yes, it is. According to Google, it is. So that's what I thought. So let's circle it. All right. So
the answer would be 4.
Yeah, 4, because there are 4. 1, 2, 3, 4.
Oh, okay.
Very good. All right, let's look at the last example. All right, set A is blank to set B. What would you guys say? What word best describes that?
It's the same, but I can't think of what word, the proper word to use, but it's the same.
It is the same. So in math, we usually say equal, right? So there you go. equals fine. Yeah. All right. Symbolized by, you can just say
3
equal.
elements?
3 elements.
I think they just want equals. But
Oh,
you can, yeah, because what if this would have been like California, Arizona, New York? That's
oh,
still 3 elements, but that doesn't make them the same, right? They're not the same.
no.
Well, what makes them the same is that they have the same elements, but just in a different order. So you would just say symbolized by equal sign. So you can just say A equals B, in other words.
Oh, okay.
Got it.
All right, let's look at this next one. What is the cardinal number for C? Remember that notation just means cardinal number.
4?
Yeah, 1, 2, 3, 4. Very good, 4. All right. NC is 4 to, whoa, that's weird. What do they mean? Is 4 to, and I don't know what they actually want there. What do they want? Let's see. Is equal to ND. Yeah, NC is equal to ND, symbolized by NC is equal to ND. I guess I just want you to see the difference. Here, the sets are equal, but over here, the sets are not equal, right? They're different, but their cardinal number is the same. The cardinal numbers are equal, but the sets are not equal. All right, so over here, you could say, but C does not equal D. So that's the difference between these two problems. They have the same cardinal number, which means that the cardinal numbers are equal, but the two sets are actually different. Over here, the sets were the same and the cardinal number is the same. So hopefully you see the difference. All right, the set that contains no elements is called there's 2 names for it, the empty set or the null set. So there's 2 ways to say that. If the set doesn't have any elements, it would just be like this. It's symbolized by 2 braces that are empty. Or you can just do a 0 with a slash through it. That's also the empty set. So there's 2 ways to say the empty set, and there's 2 ways to symbolize it. And that is it. All right, we are done with this section. I think it's a good time for a break. Let's see, what time does this class end? Anybody?
9:30.
Questions are to these. So for the first one, 25. Anybody get an answer for the 25? We'll just call it A. What would that start with?
11.
Yeah, I would say 11 because it says between, so it doesn't say including 10 or inclusive, so it just says between. So I would say 11, 12, 13, dot, dot, dot.
Dot, dot, dot.
To 177.
177.
Yeah, you got it. All right. What about the set of football players over the age of 70 who are still playing in the NFL?
None. It's not
None.
defined.
None. So that would be
Not defined.
Not defined. Okay.
Oh, you could say no, it is defined. You would just say
You can define that, but it's still no.
it's still empty, right? Because there's nobody. So just put the 2 braces with nothing inside it, or you can do the line, the null, the empty set like that, the circle with the line. So either one's fine. Either the circle with the 0 with the line through it, or the empty set. That's it.
Okay.
And then the next one would be the set of cities in which the number of international visitors was greater than 10.5 million. Oh man, that one's gonna be, I don't know, that takes too much research. We'd have to look that up to see which cities has international visitors that's greater than 10.5 million. That sounds like too much anyways. It's probably gonna be empty, right? So let's just skip that one. Some of these problems are a little too out there. So if it's a little too out there, you can just skip it and do a different one. So let's look at one more problem and then we'll be done for today. So I'm going to go on to the next page, which is 2.1 B, I think. So I emailed you guys these pages. Did you guys get them or not yet?
Yeah, we got them. Oh, I got them.
Okay, good. All right, so. Oh, I see. Actually, I didn't notice that. They gave you this. I thought we had to research it, but no, they gave you it right here. My bad. So let's go back to 33. Never mind. The set of cities in which the number of international visitors was greater than 10.5 million is, let's see, which one do you guys of these cities, which ones are greater than 10.5 million?
You want the cities or the number? The cities?
Yeah, the city.
It's 5 in
the
New
poll?
York, Singapore,
no.
Paris,
Yeah, it's the
and
poll.
Bangkok.
Okay, so Singapore. What about New York?
Yeah, it's in New York.
New York. So I think it'd be all these,
It's the
above
poll too. right?
Right.
those right there, because the other ones don't have at least 10.5. So I'm just gonna abbreviate B,
Mhm.
P, S, and Y. So you can write it like that as well. All
Okay.
right, so that's all you had to do for that one. That's all I pretty much wanted to cover with you all today. So that's it for today. So hopefully you guys get the book soon. If not, I'll